The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Hello everyone, I'm geologist Philip Ong. I'm here with Mr. Dane DuPont on behalf of Hawaiitracker.com, giving you guys another Kīlauea volcano update here on Monday, February 15th, 2021. This is the 57th day of this eruption. We're closing in here on a 2-month milestone of this ongoing summit eruption of Kīlauea. And I'm starting you guys off here with a special animation I made of the thermal camera time-lapse rocking backwards and forwards here. So we're going to spend most of our time today looking at the USGS Hawaiian Volcano Observatory web cameras. We've been compiling all the imagery, thanks to Bob Martin. Shout out for that assistance. And we've kind of trying to show you guys what's happening with that kind of view today, since we don't have a whole lot of other imagery or new video from the USGS to share with you guys. So yeah, we'll start off with here. This is the F1 thermal camera view from west to east. So north is about in that direction over there. And you can kind of see what you're looking at as the last month zoomed forward over 2 seconds and then backwards over 2 seconds. So you can really see a few changes I want to point out here. You kind of see that you kind of right at the threshold is right when the back eastern half of this lava lake crusts over. It's crusting over only on top, almost like the skin in a soup kind of thing, but still liquid underneath. Possibly more gooey on this eastern side than it is on the western side, right next to the western vent. The western vent being right here, you can kind of see it growing. rising and falling. You know, it's only just rising to remind you guys, and I've kind of played it forward in time and then backwards in time, you know, to kind of accentuate the effect here. It's easier to see. So yeah, you can kind of see that the whole surface is actually rising, right? Not just the island. You can kind of see this big island here in the middle is definitely doing a little bit of a spin and a little bit of a rise here at the end. But this whole back eastern half is also slowly rising. You can kind of see it as it sped up over the past month over 2 seconds here. All right, so that's just kind of one view of it, right? And kind of see that. One thing I wanted to point out is keep an eye on the island, and in close detail, even here at the end, it can be seen to be rising and even wiggling a little bit there at the end. Another thing we've been looking at, keeping our eye on, is this feature on the knob here on the southern end of the island as well. So if I pause it here at the end, let's see if I can get one of these frames. It doesn't even show up on that one. So let's show it to you guys. The view for the last nine days or so. So the lava level has been rising and falling. We've been documenting that over the past few weeks. And the lava level here is at its lowest. It's kind of coming up, and it hasn't quite made it around the backside of this big island. And so we're kind of playing it a little bit slow here, so we can look at some of the details, like some of these other islands that had emerged and are now resubmerged underneath the lava level. And even as lava is coming up, we see squeeze-ups on the outer ring of that large kind of piston head. That's that solid lava crust. You can kind of see a flare up over here, flare up over here, another one over here. And all the meanwhile, wow, this perched lava pond that's now kind of this crescent shaped over here is still rising upwards, building a levee and occasionally spilling over its banks on one side or the other. So that's the kind of slow version of it there. And let me play it a little bit faster. I believe it's this one. You can see there's a whole net gain. Everything is rising upwards. You can see that on top of that, the lava levels pulse. It kind of comes up and around, then it recedes, comes back up. And that's just all sped up the last month also, in about 5 seconds in this case, all forwards. So that's the status of the kind of long-term trend. That's kind of, if we take a step back and look at these longer periods of time from time to time, we can really see the long-term effect we really can't see if we look at, for example, if I flip to the USGS webcam here, the last 24 hours automatic, which is fantastic. You can see some of the similar effects, some of the flare-ups on the edges. You see the circulating lava lake up here on top. But it's harder to see that whole effect of the thing rising if we just look at 24 hours at a time, and an eruption is going on almost 2 months now. So here are the islands. This is the island that was the heart island right in here. So it actually was photographed from the other direction. So the heart was something like this. And it's still there in that little shape. I can probably zoom in a little bit for you guys. I'll redraw that heart. It was something like that. And its lava levels came up around the island. So the island's still there. That shape is a little bit different from time to time. And that's the thermal view. So you can see not a whole lot of action on the backside over here of the island. You kind of see this onlapping. But as we now know, this whole back crust is rising, and it's kind of a question of whether the lava lake will lap onto it on top, or whether it goes underneath there and lifts it up, and the whole back lid, so to speak, can raise, and that accommodates lava volume. So it's not quite clear, you know, how much of each, but you certainly see when you see these squeeze ups, you imagine there's at least some pressure of lava dumping into this side, pushing against whatever is in here, if it's not in fact circulating as a whole, right? There's some areas like here, this is what I was trying to point out before. Some areas like this little knob right in here that's kind of seem to merge. This area right in there is mostly a low spot. It's right at lava level, and as the island is rising and the lava level is relatively lowering to it, and is also forming this lower ledge along the edge, right? So we have this lower ledge down here. It's not as easy to see in thermal. And there's an upper ledge. We'll point that out on a visual one here shortly as well. But a couple of different terraces now of different lava levels. And so you can kind of see it looks like the lava is actually going into that little bay right in there. You kind of focus on this zone right in here. So it could very well be going underneath this knob and circulating at least with over here, and possibly beyond that, you know. So it's hard to really see. We can only see the very edges. This could be happening all the way through to the back and pushing lava up the edges there and there. So I appreciate you guys' questions. Dane will be collecting the questions, manning our streams. Mahalo, Dane. And if there's any of you guys that want to jump in, just let me know. All right, so that's the F1 camera. Just reminding you guys, viewing from the west, so north in that direction. So if we switch to the S1 camera from the south, north is now in that direction, so we can see a little bit better shape of this west vent. This is a USGS HVO's automatic last 24 hours. So we'll look at a couple of things here, zoomed in a little bit. The west vent, no major changes. You still have these glowing holes at the top where a lot of the gas can come out, right? That's interesting because you'd imagine if the lava was erupting out of the bottom of the crater, like through some crack and through the lake, then all this gas would have a chance to mix with this lava and make it more fluid, more frothy. So you know that there's still quite a lot of gas in there because it's still bubbling up and having this little standing little dome fountain like we had before. But there's quite a lot that's being lost through that chimney as well that you possibly wouldn't have if you had lava coming out through the whole lava lake, for example. So that's an interesting dynamic to keep an eye on there, you know, regardless of how rigid or coherent this cone ends up being as this lava lake ends up rising, right? So this, I don't know if you guys remember from a few months ago or, you know, a month ago, that cone was quite a bit deeper and the lava level was kind of looked like it was more over there. So it's really filled in. It's still climbing up the cone, but essentially it's not really blocking off that vent. It seems to be rising the lip, and lava still comes through some presumably under this level entry point, and an upwell is right at that entry right there, and that's essentially what's feeding the lava lake. So it does come in from below, but it comes in from below right like that, and it allows that gas vent at the side right over there. You can kind of see the edge of this perched rim over here. Not as many overflows recently. The lava levels there have been a few overflows, but the lava levels, as they've been repressurizing, tilts have been increasing. The volcano has been repressurizing. We have seen a few more of those overflows, whereas we saw less of those when we're at the bottom part of a deflation cycle. So I'm going to pan it over here. And that little knob, that little low-lying spot is this area right in here. So it's kind of a low terrace right there. You can see the high terrace has this shape, like that. And the low terrace has this shape, like that. Right? So, and this, calling this upper part of terrace because it's flat on the top. There's this kind of flat zone. And then up here you have your cinder pile. It's all cracked up and steaming. So it's kind of the topography of that raft of land right there. So it's not as easy to see just on this one image as well. But if we go to, I've compiled here just daytime views of the S1 camera. I'm just going to manually advance that kind of fast. I know it's kind of flickery. But what you can maybe see, if I rewind it here to the 7th, 1 week ago, we don't really see that knob. It's coming up a little bit down here in the south. But it's really from that point forward. The lava starts lapping up and onto it. And then it seems like the whole island actually rises and tilts a little bit this way over here. and something that's a little bit harder to see in this day-to-day. So let me see if I can accelerate it backwards. I know that the camera is shaking too, but I think beyond that, you can see that the island is moving up and down as well. And this is in the last 3 weeks. 3 weeks to a month or so. All right, so that's the view from the south. There is another camera worth checking in on today, and let's leave that one for there. And that's the KW camera. So view from the west, I have it zoomed in here. Here's kind of the USGS webpage, still view, and then the animated 24 hours. I'm just zooming way in here. As you can kind of see, there's the west vent right below. And there's the island right in here. You can see the edges of the circulation of lava there. Kind of maybe a little extra bay over here. So I can zoom into this one. Perhaps a little more. No, that's about it. But maybe you can see a little bit better. There's a little lower lava bench. And then a little higher lava bench right in there. May not be the best resolution for you guys there. So, all right, that's the web imagery. Here's our deformation data from the USGS. This is the Wikahuna tilt meter. And first thing to look at over here on the left is our scale. We're looking at the tilt of the ground in microradians in this case, but our scale goes from minus 0.5 to positive 0.4, about 1 microradian in total on the left. So we have had a few fluctuations, you know, slightly down, slightly up, slightly flat, slightly down, slightly up. But all of this is, if we zoom out and look at the past week, right over here, coming up from, thank you, zoom, right? Coming up from that larger deflation event we had, we'd come up from minus 3.5 microradians to positive 2, so 5 microradians total. And we're zoomed into this last little bit right over here. We're kind of just wiggling down and up a little bit. So really fairly stable and not a whole lot of change. You could have, this might be something to do with the, you know, the outflow of slightly gassier or not slightly gassier lava. It's kind of hard to tell what's happening there. But you can have natural fluctuations for many, many reasons. And that scale change is nothing that's really indicative offhand without closer observation. So here's our last month. And that second deflation we came out of was this actual smaller one after the big one that came before it that lasted from the beginning of the month, more or less, right? So a big deflation volcano, a big inflation, and then a smaller deflation, inflation afterwards. And here we are kind of just adjusting a little bit at the very back end of that. And interesting that we had a similar pattern if we go back to not quite a month ago. We had a deflation, inflation, followed by a second deflation, inflation that wasn't quite as big. We have to kind of ignore this bump with the rain right there, right over there, right? So this is the rain bump. So really our signal is pretty close to what we had here. A bigger one, although a more recent one was a little bit more dramatic difference in size, and then going back up like that. So the green line is Pu'o'o. This is that rain event that we had across the east side of the island we've documented. And so that's where that rain bump corresponds over there. And so that's an interesting signal on the East Rift Zone. And we talked about how that might have been a rain-induced adjustment, you know, and the scale of it's what's really notable. Somewhere from, let's call it 8 microradians down to, let's call it, I don't know, minus 7 microradians, 15 microradian drop during that event, kind of combined rainfall effect and whatever adjustment there was. And although it's running off the graph over here to the left and behind our label, our green line started off up here somewhere close to 25 microradians before getting down to 10 microradians before that drop happened. So it actually drops 15 microradians at least before, and there's a rain and a little adjustment. And then since then, it has continued to come down a little bit, coming down from maybe minus 6 to -12, another 6 or so microradians. So the rift zone is still adjusting. The ground is still settling there for sure. Nothing to be alarmed about as far as any lava activity, just the ground settling from essentially exhaling from all the lava leaving that area and moving towards the summit. It seems to still be the effect. And that's kind of based on the fact that if let's just go down here to the Pu'o'o cone, this distance across the rift zone from north to south, since the eruption began in December, has continued to contract and downward trend. It hasn't come and stabilized, for example. It's continued to contract, which means it's still in a state of adjustment over at Pu'o'o, right? And that's kind of the fall effect after the 2018 eruption. That's still kind of the big, we're kind of still hung over in some senses from that whole event. The whole readjustment since then and now in context is really kind of just a small little drop compared to how much it's adjusted since the eruption ended and during the eruption 2018. So one last thing on the GPS here, we'll come back to the summit and look at the summit caldera distance measurement. So here is our 2020 December eruption, and you can kind of see these cycles that we've been pointing out seem to correspond to the tilt cycles as well, like an up and down and up and down, up and down. And so we're actually back here and up, at the overall trend being an upwards one. So the caldera is still spreading from north to south, and that's indicating some interplay of magma coming in and filling the area. The south part of the caldera wall, as part of the south flank, possibly moving and shifting, and then allowing magma to come in. It doesn't matter who's a chicken and who's the egg, really. There's still an adjustment like that happening with the caldera wall moving, the south flank moving, and magma seems to be filling that spot. So the long-term trend, really, right, since about a year ago when this graph goes here, you can kind of see we can go back to the past 5 years, really, but really since eruption ended in 2018, we've been on a slow spreading of the caldera walls, indicating magma filling in. And so we had a small relief when a vent opened up, but we're actually continuing that pattern still. And that's the pattern of magma coming into the volcano. That's what we've essentially had since late 2000s, right? Mid to late 2000s is when the trend really turned around. So that's what we have for the tilt and GPS. That's the deformation instruments. Here's our lava lake depth. You get a little bit of noise up here just because of bouncing off of steam and rain clouds and that kind of thing. So just pay attention to this curve down here, and it's just kind of very steadily, slowly rising. So we've come up, I believe, a meter in the last 2 days, and our latest number is 217 meters, 712 feet deep underneath that west vent. Right. February 12th, SO2 measurements, 1,100 tons per day. These are the lowest measurements of the eruption so far, and much lower than our average for the long-term 2008 to 2018 lava lake. That was 5,000 tons per day. And it kind of varied, but you'd rarely see it get below 2,000. And we certainly have been below 2,000. And so that's still our kind of big question that's playing out in slow motion, is what's happening with the gas? Is it just, are we relieving some pocket of the magma that was gassier and the volcano is pressurizing from below still, and the eruption can end? Or is it being repressurized from below with some connected way where we're going to see some change in some gassier lava, or some new possible vent, or some changing of the configuration of the vent, or something more dynamic like that? That's still kind of the big open-ended question. We don't know. I'm sure that those questions will be coming in. We'll take them here shortly. But just to finish off the data part of it, we will show you guys our VOG forecast here. And today I'm showing you guys the whole island chain, main Hawaiian Islands, because despite the fact that our volcano is down here in the southeast part of Hawaii Island, you can kind of see that the winds have been blowing it across much of the other islands, at least according to the forecast here. So this animation, I think it goes over 24 hours. So you'll see that it actually will clear out, but then you'll kind of see when it restarts here, you'll see it's going to go right across all of this zone right here. So here it comes. I'm going to play from the beginning, because interesting, the people over here in Puna by the 2018 eruption can have some of the cleanest air in the whole whole state, even though the volcano is right up the hill. Right. There's that effect on the Maui or on Oahu as well. Okay. Earthquakes are typical as well. Get a few at the top of Mauna Loa. 2.0, 2.2, 2.1, 2.8, and a typical South Pahala hotspot feeder zone earthquakes as well. A couple adjustments in Kīlauea south flank, 2.0, 1.7, nothing at the summit. It really continued to stay quiet as the pressure has not been really building apparently, right? That's the one signal we see is the spreading from that, when we zoom in here on a caldera, spreading the GPS station from one that's about up here, the other one over here somewhere. That north to south distance is what's getting farther apart, right? Even as the gas is decreasing, and even as the earthquakes have stayed low, and the rift zone continues to stay kind of flat as well. So that's the data, the monitoring data we have for the volcano this week. We can turn and take some questions, and then we'll at the end finish off with some of the pictures from our audience, if that sounds like a reasonable way to do it, Dane.
Yeah, sure. To start off, we got to thank Hawaii Tracker helping make this possible. Lifetrackercom is a social media network that is community-based, trying to build a resilient community online. We have 3 ways you can support us. First way is to like, subscribe, share this video. We don't have the advertising of many, media organizations, so we rely on our viewers, people like you, to share this video to get more people to see it. Second way is to become a member on HawaiiTracker.com. It's free membership. Become part of the community there, and that's where we put a lot of our new releases and new videos and stuff like that. Third way is we do take donations. Best way to do donations is HawaiiTracker.com/support. With that, we do have a few donations that have come through on there. I want to thank them real quick. Walter H., Matthew S., Maxine C., and Brian B. Appreciate you guys. All right. So we do have a bunch of questions to go through today. Try and knock these out. So this one's let's try and stick in the lava lake first, right? What's the estimated thickness of the lava crust on the backside of the island? I assume where that shelf where it's crusted over.
Yeah, it's a good question. It's a good question. I haven't heard any estimate given. We do have, a couple of clues that we can kind of go on. If we look at just what we have in front of us with this data, you can kind of see that there's been a crack that separates this back thicker crust from this island channel, right? And that seems to be widening, perhaps. And lava comes out the back side, but nowhere in the middle of this whole side over here, this whole semicircle, does lava come through the middle anymore. So that's one clue to how thick it actually could be, right? So the whole thing is lifting, but it's all rising like one giant lid, despite the fact that it's under the pressure of rising up and wiggling its way up. It's not cracked in the middle and squeezed lava up in the middle out anywhere, right? That's the one thing. And then the other thing is our typical Kīlauea example, when we actually drilled through. I want to say it was 4 months after eruption was over in Kīlauea with only a 400-foot lava lake. They found the crust was 7 meters, 20 feet thickish, something like that. So that was 4 months afterwards with a 400-foot lake, which maybe cooled off slightly faster than a 700-foot lava lake. But we're not even done cooling. We're still pouring lava in there. So I would guess less than maybe 5 feet, 10 feet. It's got to be somewhere in that range, to be thick enough to be rigid, to not be buckling under the rising lava. But right,
right,
it can't have accumulated that much as well, right? If that's that kind of a maximum.
All right, Karen asks, is it still considered an eruption as long as lava is coming out? And
yes.
How long would it have to not be coming out for?
Well, that's the second part's more complicated and interesting.
That's the part I added on. I didn't see that on there. That's not in the question that was asked, but
Yeah,
that is
so
the question we often ask.
yeah, so I mean, it's some examples, right? Most recently, the Pu'o era had 62 different episodes, which were different phases of the eruption, and in between every one of those, there was some kind of gap in eruption, a pause, if you will, right, or a shift in event from one place to another, where you could have easily named it a new eruption, or said the eruption had stopped and another one began, depending on how you told the story. You could certainly do it that way, right? That's not how the USGS has done it. They've named it 62 episodes of one big eruption of Pu'o that lasted 35 years, right? Mana'ulu stopped, I want to say, for 4 months, maybe, between 1971, 72, something like that, before it resumed for another couple years. And that's sometimes thought of as 2 eruptions. That one's kind of borderline, sometimes 1 eruption. Nowadays, as more time goes by, it's thought of more as 1 eruption. But you can kind of go back, and some of the literature kind of splits it up into 2 different phases, right? That makes sense. So,
Right.
Yeah, if it keeps erupting out of the summit and nearby, even after a pause of, I would say, a couple weeks minimum, you can still call it the same eruption. So it probably has to be a matter of months that go by for it to be over, before we say, oh, it's just reactivated. It was just paused, and now it's going again. So that part, yeah, that's an interesting thing to consider. We just don't really know. It's kind of a judgment call.
Mary asks, Mary comments that the squeeze ups are cool. Any idea what the difference in temperature is between the source and the squeeze outs?
That's really hard to tell. Really hard to tell there. It's because we do expect there's some kind of attenuation of the actual temperature value over the distance that this camera is measuring it. So while we can see the patterns and rely on those, it's hard to really say, oh, that color represents exactly 300 degrees Celsius, or how does it compare to the other sides? I mean, I'd love to have more information on the temperature, the chemistry. If that lava, has been sitting underneath that crust for a while and is degassed, for example, and is more crystal rich, that'd be fascinating to see. Yeah, but we just don't know.
All right. So, Nightcrawler asks, what are the odds that it drains out from the lava lake down to the East Rift Zone, similar to 2018?
It seems like a fairly low chance at this point, given the signals that we see now. Now, of course, with the volcano, it's just only a matter of time before it stretches out that part of its body, so to speak. But it just did that, and normally it takes time for it to kind of build back up to that. And so we don't expect that to happen. Of course, it's nature; it does what it wants, right? So we haven't seen, we have the pattern wouldn't fit that well, and we haven't seen any signs. We've seen signs of the rift zone contracting as far as Pu'o, and then no response beyond Pu'o, so as if there's no connection. So the volcano seemed to pressurize all the way to Pu'o, and then is backflowing to the summit, which means that pressure block beyond Pu'o, between Pu'o and the lower east rift, was strong enough to maintain all the pressure that you've seen coming out for almost 2 months now. So that's the best reassurance, really. Something big would have to change.
Right. That answers a few other questions that I had lined up. If you asked a similar question, I hope that answer suffices. Mary asked that this eruption event has lasted longer than many thought it would originally. Could it possibly go on for years?
I would say yes, absolutely. It's gone on longer than I thought. When I first came into this first few days of the eruption, we thought, well, let's look back to 1924 and then post collapse and how lava lake refilled over the years. And we didn't dive deeper into the magma supply rates like we have more recently, and say, well, maybe that wasn't the best comparison. We should have compared it back to the 1800s, where we just don't have that detail of data of how that actually went. But if we have a high supply rate, which seems to be the pattern, and so far the GPS, it may be indicating that. Kind of ambiguous there, right? Chicken and the egg kind of thing. But still, I think Yeah, I'm not sure where else to go with that.
Yeah, right. Follow-up question or a similar question. Actually, it's not even similar at all. Sylvania asks, what is the likelihood that more than one volcano on the island is erupting at the same time?
The likelihood, that's a good question. On a day-to-day basis is not really likely at all. It does happen. In 1984, Pu'u'o was erupting when Mauna Loa erupted, and that eruption in Mauna Loa was 2.5 weeks long. So for those 2.5 weeks, they erupted simultaneously, Mauna Loa and Kīlauea. Right. So 1996, when Loihi erupted, Kīlauea was erupting. So you can say that, though, you had two. If you're gonna stretch and add Loihi as well, that was an example, but pretty rare.
Right. Yeah, it just seems like there's plenty of examples of it happening throughout history, but it seems like one of those things where when you have one eruption, like our current eruption, where it might possibly go on for an extended period of time at a very low rate, the likelihood of another eruption happening goes up, because now you have the hard part done, having one eruption that's going on for a prolonged period of time to give you a window for the second one to come in. It seems like kind of like when we were talking about the multiple disasters and with COVID. It's like when we were talking about it probably almost a year ago, 6 months ago, when you have one disaster that lasts for such a long period of time, the likelihood of another disaster then happening, it goes up because the hard part's done there. The prolonged disaster state is there. So now a second one, that's all you got to get.
Yeah. So chances are higher now than before December 20th. That's for sure, right? because it is
right.
It is still going on. Yeah. If we do it on a day by day. Yeah.
Richard asks, do glacial and interglacial periods affect Hawaii's volcanic activity?
That's a great question. I don't know the details, to be honest. Right? We do see that there are 3 different glaciations recorded on Mauna Kea, right? And so there's kind of an interesting effect of the mountain is settling as the glaciers are forming. So every time the glacier comes, the mountain's a little bit less. It's got a little bit different height, right? So the glacier reaches a different point on a mountaintop. So you can kind of see three different ages of glaciations there. But we haven't seen direct effects of that causing eruptions, for example, on Hawaii. There is supposedly a quarry, right, an adze quarry on Mauna Kea of that Hawaiiite kind of lava, right, that may be a subglacial eruption where there might have been an eruption underneath the ice, as is common in Iceland and that kind of thing. So that kind of thing is possible. I would have to defer to all the guys at University of Hawaii who are really more familiar with that. And but I can tell you that exists. Yeah, that's the case. Yeah, and there are cases elsewhere along in a world where if you have a giant glacier that's really depressing an area and it all melts fairly quickly, you kind of have the mantle rebounding and pushing up and pushing the crust upward, and have kind of volcanism in that area, caused by that, if it's like a big enough kind of thing. Our islands aren't big enough to sustain that big a glacier, really, but maybe locally from one place to the other, if you have like all that pressure on a volcano, and the idea being it takes years for you to accumulate snow and build a glacier up, so the volcano can adjust as it happens. But then when it all melts at one time, suddenly you relieve pressure, and if the volcano has got enough magma pressure inside, it could erupt just from the thing melting. So, but that's really hard to associate, and I haven't heard it happened. Haven't heard of it being done here in Hawaii.
Brian asks, how much is Kīlauea and Mauna Loa study compared to other regions of other volcanoes?
I think Kīlauea is one of the, if not the best studied volcano on the planet, right? And that's partly because it has had long sustained eruptions, and that makes it a great laboratory to kind of come in. And it's kind of eruption where it's not a run for your life kind of thing most of the time. There are times, such as 2018, where that was, people were running for their lives. But
walking briskly in some cases.
Yeah. Yeah, or we're supposedly following a drone or not following a drone, or who knows exactly. But in any case, people had to like abandon their cars and things like that. That's for sure, right? Because lava was moving fast enough for that. But most of the time, it's in this perfect lava stadium right there, and you just look down in a hole and you see what's going on in there, and you can kind of take your newest instrument or gadget or technique and come test it out on Kīlauea as a proving ground for all the science, all the instrumentation, and to train all the scientists that, if you want to go and be an expert at some other volcano in the world, you don't want to have that volcano's eruption be the first eruption you ever see. Where you're likely to go beforehand, Kīlauea is a top choice, right? Because it's a likely place to be erupting when you're doing your research.
Likely to be erupting and ease of access. I mean, you take a plane, land in Hilo, shoot it up there, in 40 minutes you're standing on the caldera rim.
Yeah,
without walking much at all.
Yeah, it's one of the world's drive-in volcanoes, right? It was a little more drive-in before all the collapse, but you can still drive in a good ways of it. Yeah. So that's really it. And Mauna Loa, is less studied, a little less. It's kind of because it's a little harder to get to. It's bigger. There's less access to its summit. Right, it hasn't erupted as continuously in the recent modern era of science, right? So that's kind of an interesting thing. So we're kind of trying to catch up in Mauna Loa.
Right. Well, I'm going to combine two questions here. Jim asked if they've gotten any lava samples from the eruption, this one currently going on. And Nightcrawler asked, is it old magma from 2018 or is it new injection from the depths from the plume?
Well, we've only heard of one sample so far, and that was from the first couple of days of the eruption, I believe. It's not quite clear if that was integrated beyond that. And that was magma that had been stored in that shallow chamber, kind of the remnants of the magma chamber that fed 2008 to 18 lava lake and a 2018 eruption in Lower Puna. That same kind of magma that had a big vent that gas would flow out of all the time. So it has a particular degas kind of signature, right? So that was the first stuff to come out, but that presumably it's building pressure from stuff pushing it from below. So at what point do the pipes get kind of flushed through and you see the new stuff come out? That's to be determined, and we're still awaiting more information on that. And at some point, could be months, could be years, we expect it to happen.
Tim asks if you can explain how certain minerals and ores are created in the lava that we see. Just briefly go over the crystal structures as it cools, or how does it become sulfur or gold or iron or that comes up with it get created.
All right, let's see if I can do try to impromptu simplify it here. Yeah, because that's a whole field of research that's super complicated, and it depends on the pressures and temperatures and all kinds of details like that. So mineralogists we'll go into lots and lots of details of expertise of that. But essentially, if it's coming out by gas, is how you often get your sulfur deposits, right? That's kind of often how you see the sulfur vents. When it's cooling from the lava chemistry itself, like the bulk of what's in there, you're going to form largely olivine and feldspars and pyroxenes, which are certain classes of minerals, right? And that's just because that's what you have mostly in the magma. Now, there's all kinds of things that are called incompatible, things like gold or arsenic or whatever there is that is in the earth in any minute amount. That stuff's trying to get away from the magma as soon as it possibly can. And so usually, if there's any kind of groundwater that's hot, like anywhere around the edge, any of those cracks near the magma and the gas moving through there, that whatever that stuff is incompatible will try to get out. And oftentimes the volcano has to kind of die, and then that steam or water saturated with gold will cool, and then you have a gold vein that forms, and eventually the thing gets eroded down. You can find gold on the surface, somewhere like that, right? But so it's hard to really see any gold anywhere, right? Really, right? Especially when the volcano is like at the surface like it is now. So you go somewhere that's much older and it's been worn down, you kind of have a glacier slice a volcano in half. You can see the crystallized center of it, and you can see more of that kind of stuff. Right? That's what a lot of the American West has that kind of situation, and that's not what we're dealing with here. So, but that's kind of the big picture, right? So the lava that we see here is basically making what normally is olivines, is what you see. If you use a microscope, you can see the pyroxenes and the feldspars of various kinds, and lots of glass, which has essentially is the soup that hasn't had time to crystallize into those forms, right? It's kind of like if you have a glass of water and you put it in a freezer, it's going to form the mineral ice. And if you put a glass of, I don't know, something else, then it'll crystallize some different material, right?
Right.
So.
We have a question from YouTube. Will Lailani become the next Royal Gardens? For those that don't know, Royal Gardens was a subdivision near Kalapana that was inundated with the eruption of Pu'u'o'o over the course of, 2 decades? Maybe a little more even. But most of it done in those first 2 decades. And there was, I still believe there's still street little segments that you can see.
There's a little bit that survived in the end, yeah.
Just a little bit, but most of it got destroyed. Yeah,
and that was because of the long-lasting sustained eruption of Pu'u'o'o that went on 35 years. And so Ahu'aila'au, aka Fissure 8, did not go on 35 years. It was massive for the 3 months that it was. The eruption was 3 months. I guess it was 2 months of Ahu'aila'au reactivated at the end. That was really the terror of the lower Puna there.
Mm.
And there's been no change, really that I've heard anything. The ground is still settling there. I mean, imagine that, if the ground is still settling over in lower Puna, an area like Pu'u'o'o, it's got to be really settling quite a bit. Everything is just still settling. It takes years.
Especially when the South Flank's still moving at an elevated rate. It's like trying to settle while adjusting and settling to the adjustment, which it's then adjusting to. So it's just interesting.
And maybe that's why it's harder for that lower East Rift to really get in any action, is because the South Flank by the lower East Rift doesn't move nearly as often. We haven't seen earthquakes, like around Kapoho, nearly as much as we've seen them south of Pu'u'o'o over the last 2 years.
Right. Kelly asks that doesn't hear much about the earthquakes under Hualalai, Kohala, and Mauna Kea from where they live in New York. Do they have large amounts of magma moving under them, like Kīlauea or Loihi or Mauna Loa?
I wouldn't classify it as large amounts of magma, right? Most of the earthquakes that you see are kind of what we'd call a background activity. It's just kind of either a settling or adjustment of the whole island to moving away from the hotspot, to cooling off its own volcanic structure, to erosion, to whatever else is happening, right? So there's kind of a background that's kind of normal, and only if you see the earthquakes come back in a pattern of volcanic, indication, which is normally rising from deep to shallow, and in swarms that are normally amount to thousands per hour, right, or at least hundreds per hour of earthquakes, right? So not very big ones, but lots and lots and lots and lots and lots of small ones, and localized in space, right? Not kind of all over the place, but like along one particular lineation or feature like that that's visible underground. So that's what you look for, and none of that's been seen. I don't believe in a long time. I want to say Hualalai had an earthquake crisis in 1929, perhaps. Not quite sure I'm remembering the year correctly there.
I thought that was 1829.
It was 19. It was.
Okay. I thought there was one right afterwards, after it erupted, like not too long after.
Yeah. I think there were a few, right? But
right.
I want to say there might have been one in a modern era of volcano monitoring, perhaps, in the 1920s on Hualalai, but It did not actually erupt in the end, and so we really don't have any information. I mean, it's not like now, right? We're looking at earthquakes on Hualai from the instruments on Kīlauea for the most part, where there is no Hualai station that was deployed by Thomas Jagger in that era, I don't believe.
We might want to do a segment on Hualai one of these days.
Yeah, we'll have to.
That'd be good.
We'll have to. We'll have to look into that a little more, and maybe find a special guest to bring on, because that's a very specialized volcano there.
Right. Very much so. We have one more here. It's a question from YouTube. If the Galena slump were to slide rapidly in the ocean, is there a chance it could also cause an eruption from ocean water entering a magma chamber?
I mean, if you could, in general, have any kind of earthquake, let's just generalize it to any earthquake, right? If you have any big earthquake that can juxtapose water with magma, then you could have explosions for sure. And you could have eruption, explosions could open pathways that magma can then come out of, right? So that's kind of all fair game. And, whether it's, you want to lump that with Helena slump or not, big earthquakes can do that. Now, like right now, there is water that filters through the whole volcanic pile and is relatively near to the magma, but it can only get so close before it vaporizes and becomes part of the steam sleeve or whatever that's around the magma bodies as it exists in 3D under the ground throughout the volcano. Right, so I mean, it's not the fact that it's there; it's the fact that it has to be there and shift suddenly, so that the water is now suddenly able to get quickly to the magma before vaporizing, and then it can cause that kind of explosion. So that kind of thing is possible, right? Normally you don't have that massive thing, but we really don't know what happened in that earlier era of explosive eruptions of Kīlauea, where that was the common thing every few decades for centuries. So there's a lot of unknown there. Now, as far as Helena slump, Helena slump might be something where you go back and do another segment on, I think, at some point, right? You go back to the original when it was first put out in the literature, right? There was an earlier movement that was larger, that when a volcano was growing and still at equilibrium. But since those initial early growth of the island landslides, the thing is creeping along, right? It's not like a fast moving. It's described as a slow moving feature, right? That's what they term a slump to be in the literature when you look at Helena slump. It's a slow moving feature today. So it really can't be. It's not likely that it's going to race off into the ocean. It's not in that phase, and it's not the right shape to be collapsing. And the volcano is in equilibrium now, and perhaps after the volcano, the Kīlauea stops erupting at some point, and then the south flank starts shifting, and there's no east rift pushing, and it's settling in some weird way. Then you could have landslides again, but that's not going to happen in an instant. That's going to take geologic time to pass, and the volcano to stop erupting first. So as long as Kīlauea is going.
He was kind of asking, you put a follow-up that in relation, like a similar scenario to Krakatoa, is what he was envisioning there.
Yeah. So I mean, Krakatoa. I mean, there was that kind of landslide of the side of the island and seawater coming in, explosions. Yeah, that was the most recent kind of global news of Krakatoa, right? Even though it's done other things since then. And our volcanoes on Hawaii are much broader, right? So that whole island volcano that collapsed, that whole thing would fit inside of our large, flat pancake pile. That's really broad and wide, right? So we don't, and it's true that at the edge, the Helena slump does that's the edge of the fault scarp, but it's not as steep like that. And it's not that same kind of shape, and it's not as unstable, right? There's a lot of other. Right. It's like a lot broader structure overall.
Natasha has made a $5 super chat. Thank you guys for covering Kīlauea. She has always fascinated me. Mahalo for the donation. Appreciate it.
Mahalo.
So we do have one more here. Patty asked, what are the most likely scenarios from where Kīlauea goes from here? Before you answer that, I just looked up Kohala in 1929. Apparently there was also an earthquake swarm with a 5.5 and a 6.5 with $100,000 in damages in Kona district at the time, according to Ken Rubin.
So there you go. It was 1929. Yeah.
Yeah.
Yeah, earthquake swarm, exactly. Yeah. That's really the most noteworthy one of that question, right? That is not really... Yeah. I mean, Mauna Kea's got interesting earthquake patterns, so we can leave for another time, but nothing that's like volcanic and, you know...
Yeah,
Hawaii did have that one, yeah, in the most recent time.
Right. So back to Kīlauea, what's most likely scenarios from here and what to look for?
Well, so yeah, I mean that's really the prognosis is what the pressure does. You know, I mean we're looking at here. I've been playing this in the background. The whole eruption in 24 seconds or so, right? The whole 2 months of it now, and you can kind of see that we had that initial vent open up. Now the west vent's become an active one. The west vent's been active for way longer than that north vent was, and it's put out more lava. By this point, the north vent did in those first 6 days, right? So it's hard to say that this pathway is not the best open pathway, anymore. It certainly is an easy place for lava to come out. So it could come out for a long time without stopping, and that's kind of what we're looking for. What are the signs that it's showing of putting out lava for a long time without stopping, rather than stopping the eruption? The alternative being we see the gas values going down, and if the gas is going down and the amount of lava coming out is less and it's coming out as denser, maybe it actually gets gummed up, so to speak, right? It clogs its exit path, and it's allowed to repressurize, and it might repressurize for a month or two, or a week or two, or who knows, and then erupt again somewhere within a caldera, and resume the lava lake, and maybe disturb the crust and the gooey center of it, and that kind of interplay, right? So that's really the question. It seems like long term there's more magma coming into the volcano. That's been true since the early 2000s. It doesn't seem like that has changed recently at all. So long term there's going to be plenty of eruptions on Kīlauea, whether it's one continuous one or it starts and stops and starts and stops, which is more the pattern that history shows us. It doesn't really matter, right? That's kind of the interesting part to see. And the prognosis seems to me mostly, for those who are worried about where else it might go, it seems like it's likely to stay at the summit because it's an easy way out, and that might be the best nozzle for a long time.
All right, well that does it for me on the question side. I'm sorry if I missed any. Going just over an hour now. Yeah, appreciate everybody that stopped by today.
All right, so we'll just finish it up with a few quick photographs from Hawaii Tracker. So this is taken from the Facebook group here. This one's by Phoebe Jux. I'm sorry if I butchered your name here, but Halemaʻumaʻu crater, iPhone 11 here with the uluhe ferns in the foreground. Very nice submission there. Some views of what Kīlauea looks like now for the visitors, general public, right? This is Kodi Yamaguchi, and you can see here Milky Way and glow from Halemaʻumaʻu together. I'll check it out in higher definition Hawaii Tracker. This one, VJ Das, Kīlauea Overlook. You see the glow and all the gas and some stars shining through here in the background. A couple of last ones from our old reliable Harry Durgan. And view Kīlauea crater. This is Kīlauea Iki here in the foreground. You can see the trail here going across the bottom. And Pu'upua'i. And here behind it, within the caldera, Halemaʻumaʻu glowing. You can see the top of this steam cloud right here, right? So this was December 23rd, when we still had quite a lot of gas coming up in that the volcano. And one is more recent, February 15th, earlier this morning, from Mauna Loa Road, Kīlauea crater, and you can see nice astronomical shot as well. So check those out in high definition, HawaiiTracker.com. Thank you guys for joining us today. We'll be back to you guys on Wednesday. We'll catch up on what else is happening on Kīlauea volcano. And we'll prepare for the 2-month milestone of this eruption coming up at the end of the week here. All right, so until then, on behalf of Dane DuPont, I'm Philip Ong. Aloha, everyone.